One last formality I want to get out of the way before we get into some more attribute stuff after this. In our SOPs section is I just wanted to cover what the copy stamp is. Copy stamp is a way of kind of randomizing geometry that will come up a lot if you're watching older tutorials. I felt like it was good to just cover this right now so that you're aware of its existence, so it doesn't scare you when people start using it if they're going to use it in their tutorials, as you continue your Houdini learning journey here. It's just important to kind of know what the copy stamp is, why it's here, how it works, and then I'll just kind of compare that to another for each loop example, which is sort of more the preferred way of doing things. I've found that sometimes the copy stamp seems like it performs faster than the for each loop, and other times the for each loop appears like it's the winner. So really, it depends on what works well for you. I find that both of them tend to be a little bit confusing at first, but just with a little bit of practice and hammering it away, you'll eventually start to remember how these things work on the inside. So to demonstrate, I'm going to just start with just create a very simple example. We're just going to clone a bunch of random stuff onto a grid of points and just kind of randomize some of the properties. So let's just create, I'm just going to create a geometry, and I'm just going to, I don't really need to name this. I'll just call it stamp versus for each. So we're just going to hop inside there, and then I'm going to throw it on a grid. And now what I'm going to do for this project is, let's say I want to clone a random object onto each point of these and each point of this grid, and I want to choose between 3 objects. So we're going to choose, we're going to create a cube, and we're going to create a sphere, and we're going to create a torus. So we've got our box, we've got our sphere, and our torus. And we just want to clone these onto the grid, so we're going to need a copy to points. Copy to points is the new version of the copy stamp node. Now, copy stamp has been moved into its own node, so we actually can't use this for this example. So I'm going to delete that and start typing copy stamp. Copy stamp. And you can see if you zoom in on the node, it has a bunch of different shapes on each point. This node is remaining in Houdini to be able to support older setups and stuff like that, and it's just important to know that it exists. So here you get a bunch of different options here, including this stamp tab. So we'll get to that in a second. But first, what I want to do is throw down a switch. And we're going to use this switcher to switch between our box, sphere, and torus. So I'm going to select all of them and then drag from one of the outputs in here, and you can see it wires them all up. And then our switch here, we can select our inputs between our different shapes. So cool. Now, if I wire this into the copy, these are the primitives we want to copy, and these are the points we want to copy them onto. And then I select my copy, you can see that it's just selecting whatever our first input is on our box. Now, if I go up here and I switch this box, now we're copying all the spheres, and now we're copying all the toruses. So what a copy stamp will allow us to do is create a little function that will it will actually send information upstream and start modifying which input of the switch it's using up here. So to do that, we get into our copy, we go to the stamps tab, and we tick on stamp inputs. Cool. So now what we have to do is we have to create a variable. So for our variable, we're just going to call it S for switch. And in our value here, this is where we write our little function. So we want to pick a random value between 0 and 3, or between 1 and 3, which actually in computer language, if you look at our switch, our inputs are going from 0 to 1 and 2. So really a random value between 0 and 2. And to do that, we can just use a random function. So we're going to type in rand and open bracket, and then here we want to feed it a seed value. So for a seed value, we're just going to use ptnum. So at ptnum, that's basically, if I look at the grid, and I turn on the point numbers, you can see each point has a different number. So it'll be a different seed value for our copy stamp to use. Now I didn't finish writing this function, so I'm going to just close that off. And there we go. So now, just knowing the way random functions work, they create random numbers between 0 and 1. So you'll get 0.001, 0.234, 0.984976, it's just a float value between 0 and 1. And we need that to be from between 0 and 2. So in order to do that, if we multiply now by 3, that's going to create float values. It's just going to multiply all the float values that are created by 3. So we'll get some values that still remain below 1. Like if we had, for example, 0.01 and we multiply that by 3, we'd still have 0.03, which is below 1. So when we floor this, which it will just wrap this whole thing inside of a floor open parentheses, and then close parentheses around that, that's just going to round it down. So 0.03 now rounds down to 0. And, for example, if we had like a 1.4, that would round down to 1. It would be floored to 1, and so on and so forth. So anything that is approaching 3, if we have 2.999, it's going to floor to out to 2. So now this S variable is looking here. This S variable is created to be referenced by a copy stamp function upstream, and it'll know that it's going to be generating just an integer value between 0, 1, or 2 randomly. So let's just implement this. We go back up to our switch, and then where it says select input here, I'm just going to right click and under expression, and going to hit edit expression. You can type it directly in here if you want, but I'm just doing this to make it a little bit easier to see. I'm just going to type in stamp. So stamp is a function. You just open the parentheses here, and you just got to give it a node to look at. So the first thing it's expecting to see is which copy stamp am I looking for. So we're going to look for copy. If we look down here, it's copy 1. So I'm going to type in COPY. You can see it starts to fill it in for us. I'm going to hit down and hit enter, and it has filled that string out for us. I'm going to close the quotes. And the next thing that it is expecting is our variable that we created. And we just put that in quotes. I think the variable we created, if I look here, yeah, we created a variable S. So that variable it's expecting is S. So put that S in quotes, and then you just got to give it a default value, which we'll put in 0. That means like if for whatever reason it can't come up with a correct stamping variable, it's going to use the 0 input, which is the first input. So I'll hit apply and accept. And you can see if I go down here to my copy, it is inputting. I'm going to turn off my point numbers. It is randomly grabbing a torus, a sphere, or a cube. I'm going to just, let's put down a transform just after the switch so that I can scale each of my primitives down a little bit to get a better kind of view of that. So you can see here that it is grabbing random elements from our switch and scattering them onto our points of the grid just the way we want them to. So that's cool. So now this is the old way of doing things. Now there's the newer way. There's a million ways that you could do this probably, but just to kind of illustrate the example of how we can do this using a for each loop, I'm going to do that. So let's I'm going to make another switch. I'm just going to option drag this switch over. You can see it remains, it automatically wires all these guys in. So this over here is the, the old for each way, or the old copy stamp way. And over here, we're going to do the for each way. So what I want to do here is we're going to do copy to points, just regular old copy to points. This is the new one. Copy to points. Here we go. And we're going to use the grid again as well. So the grid is going to be our second input, just like the last time. And then we're going to wire this into the first input. Now it's not doing anything, which is fine. We gotta get our loop going on in order for this to work. So we're actually going to loop. We're going to loop around the grid input. So if I type in for each, And now it's just going to say for each. Now we actually want to go, we've got all these different presets. We want to go through for each point of the grid, because all the grid has right now is points. It's not, it's just a grid. You know, we don't want to go over the primitives because we're actually copying 2 points. So let's say for each point, and you can see here on the bottom of our for each and the block end, it is set to iterate over pieces or points. And the piece element is points. It's not primitives or anything else. There's no other attributes being used as in previous lessons. So now if I I'm just going to drag this top node over so that it intersects with the grid. Cool. And I can just bring that back now. And then I'm going to wire the output of the copy to points to the end of the block. And then highlight the block end. And you can see it's doing nothing again at this point. So so this is cool. Now, I guess at this point, what we need to know for the copy to points to do its thing is, well, first off, we're going to have to modify this switch. And this switch is still looking at this stamp function, which isn't going to work. So I'm going to right click and say delete channels here. And we're going to type in a new expression here. But what we need is to be able to look at what iteration of this loop we're going through. Again, loops have iterations. If we look at a single iteration, we can slide through and select each of our individual points that are on that grid, and we get, you know, up to 100, and then it stops. So we know that there's like 100 loops, and we need to know which loop we're on, because we're going to use it as a random seed to govern what switch value is being input. So in order to do this, we need to use the meta import node. So under for each begin one, if I click this top node in the for each loop, and I click this create meta import node, it creates this node that just kind of hangs off to the side for us here. And that's really it. If you look here, it creates detail attributes for us that will, you know, we can use a function in another node to look up what iteration we're on, how many iterations there are, values, iteration values, etc. To make this easier to reference, I'm going to just call this our meta node. So meta, like so. And now let's get to writing that expression. We're going to use something similar to what we did over here in the copy stamp. We're going to floor a random number based off of our point number times 3. So let's do that. Up here in switch, this is a little bit more long-winded than that other function we wrote. So I'm going to right click here under expression and say edit expression. And this is going to pop this out. Again, you could just type it straight in there, but this is going to make it a little bit easier for me to at least see what's going on. So the first thing we want to do is we want to get the iteration number that we're on. That's similar to like what point number we're on, and we can create a random seed out of that. So let's do the detail function and look at the meta import node over here. Using the detail function, it will give us which iteration we're on. So let's do that. Detail, and I'm going to look for the .. meta, the meta node. And I'll hit enter there after selecting it and close this. Then it's just another comma. So that was our first field, was the string to the path of the meta node. Then the next one is a quote for the iteration. And you can see that this iteration, it's giving us this value right here is the number we need, or is the value we need to look up. So we just type in iteration in quotes like that. And then again, here it needs like a default value of 0. So I just put 0 in there at the end. So if I hit enter and apply and accept, and I go back to the end of this and turn off single pass, you can see that for the first 3 numbers, at least, it's grabbing a different input. That's great. And then once it gets up to our third iteration, it doesn't know what to do with, you know, iteration, you know, 200 or whatever. So it just, or 100 up to 100, it doesn't know what to do. So it just simply puts in our last input, which is the torus. So now we just need to randomize this. It's quite simple compared to, you know, it's actually what we just did before. So I'm just going to right click and edit expression. And so what we need to do is create a random number out of this. So I can go throw this in a random bracket. And I want to, so now we're getting a random number between 0 and 1. And you can see that because it's a random number between 0 and 1, our 0th input and our first input are just the box and the sphere. So now if I just multiply this by 3 and hit apply, now it's picking up random numbers between, it's picking up a random object between 0 and 3. And then I don't know if this is 100% necessary, but I just like to do it anyways. I like to floor it like so. Just wrap a floor, open parentheses, close parentheses around the whole thing, and that seems to kind of bring it back to rounding every value down between 0, 1, or 2. So apply, accept. And now these are all a little bit big. Again, we have this transform node. I'm just going to option drag that over here and plug that in. And you can see here that it is randomly selecting our different toruses, boxes, and spheres, and instancing them on there. If I go back to the copy, it's funny because it's actually, we've seeded these two random functions exactly the same. This switches random function it has the same seed, but point number, as this one does over here. So, I mean, if you were doing, you could obviously change this by inside of the random function, adding another multiplier like 45. And now we get two different methods. It's also interesting that the toruses are oriented differently on each one. I'm not 100% sure why that's the case, but it probably has something to do with whether how attributes are being transferred in the copies. So, from here, if you wanted to do more stuff like randomize the rotation as opposed to just the adjust these inputs, you could do that as well. So let's just quickly go over how to do that with the copy stamp method. So in the copy stamp method, I would create 3 variables here. I do one like rx, and then I do another one like ry, and another one like rz. These are the rotation x, y, and z variables. So to get those activated, we need to make another function. I'm going to do another random of the point number, and then I'm going to seed this one times 1, 2, 3, because I want this one to be different. This can be any number. You could type in literally any number for your seed value, just as long as it's different from your other ones. That way you're not getting like, you can start to maybe, if things are seeded exactly the same for a bunch of parameters, you might start to see a pattern emerge that looks like it's not fully random. Like you'll get everything kind of rotating off to the same angle. So I'm going to just use random at ptnum times 1, 2, 3. That's going to give me a unique random number between 0 and 1, and we need it to be between 0 and 360 because we're going to be doing a 360-degree rotation in our transform node using the copy stamp. So let's just multiply the outside of this by 360, and that's going to give us a random number between 0 and 360. So now I'm just going to copy this one. I'm going to paste it into the y value. I'm going to change the random seed to 456. And I'm going to paste it into the z variable as well, and then change this one to 789. So now we've got 3 random functions between that each are seeded differently, and they're going to give us a 360-degree value between 0 and 360. So now when I go over here to my transform, I can just start with the rotate x. So I'm going to do similarly, type stamp, open bracket. We're looking for copy 1, like so. And we want the rx variable that we created in that stamp section, and we'll just default to 0 if it has an issue, and so on. So now it's getting a random rotation in x. I'm just going to copy this, move to the next one, hit paste, change it from rx to ry, and hit tab, paste again, change it from rx to rz, and hit enter. Now we get random rotations on all these values. So all those are randomly rotated, and we're good to go. And you could keep going on doing this stuff with scales and etc. So now that we did that, let's just let's try and implement that for our for each example here using the detail, iteration, etc. All right, so let's go down here. I'm going to actually grab for our for the transform, we're going to create like an additional, because writing out the detail is quite a long function. I'm going to kind of expedite that process by creating my own little field to store the iteration number that we're on. So I'm going to just hop in here and say edit parameter interface, which we covered a lot of this in our asset creation. part, but we're just going to revisit it because it comes up a lot. So for our iteration, we're going to want to have an integer value, because iteration number is a whole number value. So if I grab the integer here, because I'm going to be modifying rotation, I'm just going to put it right here next to my rotate value on the transform node. So I'm going to drop that in there, and then I'm just going to call this one iter, and then label it iteration. And that's all you got to do there. And apply and accept. You can see that above our rotates now we've got this iteration value. So in the iteration value, I'm going to write out my detail function. So I only have to really do it once. So detail, open parentheses. I'm looking for my meta right here. Oops, right there. Hit enter. And then I'm looking at the iteration, and then 0. And I'll just hit enter, and then that evaluates. So, this is one of those things, like, I know, expressions like this are kind of cumbersome and clunky feeling, but there's just a few that you need to know. And this detail one, looking for your random iterations of your meta import node on your for each loop, are just things you're gonna want to know to get Houdini to do the things that you want it to do. So I know that it's kind of clunky and it sucks, but just try to see if you can get it committed to memory and get it into your muscle memory and get used to using it, because this is just, this is where a lot of the magic happens, is by being able to iterate through a whole bunch of objects and then be able to know which object you're on and make decisions about how you're going to modify that object using this detail function. So, to make it a little bit less painless, a little bit more painless when we're a little bit less painful when we're doing this rotate function, I just abstracted this one out. So now what I could do is I could right click this and say copy parameter. So now I've got a relative reference I can paste here. So under rotate, we want to do the same thing. We need to do rand. And we don't want to do a random number based off of the seed of our iteration. So I'm going to open parentheses, and then right click and say paste relative references. So now it's got a relative reference to our iteration channel. So we got a rand here. I want to seed it by 1, 2, 3 for this one. And then when I'm done with generating my random number between 0 and 1, I want to multiply it by 360. So that it's a random number between 0 and 360 degrees, like that. So now that I've got this, I can just copy this, hit tab, paste it into the Y slot. I'm going to delete the 1, 2, 3, change it to 4, 5, 6, and do it again over here to the Z parameter. And I'm going to change from 1, 2, 3 to 7, 8, 9. Now we've got random rotations on all of these objects. And if I believe I seeded these the same, but no, it doesn't look like they're rotated the same on these two. It could be because I've got a different seed up here, but at any rate, that's sort of a comparison to you of the old school way, which is the copy stamp way, and the new school way, which is the for each loop and stuff way. I think that they're both kind of confusing when you're first getting started, but hopefully after a little bit of practice, you'll get used to the feeling of what it's like to use these. And we're going to cover all this stuff a little bit more when we get into the attributes section in our next chapter, which is arguably, I think, the most important concept to even know about Houdini is how to use attributes and manipulate them as they flow through your data like this. And you can use your attributes to govern these different rotations on your copies and all sorts of stuff like that. Like, the possibilities are endless with attributes. So before we get into that, just wanted to cover this a little bit so that you could have sort of a primer for how we can be using iteration and looping to create randomness in our scenes, and also just so that you could know about the copy stamp and that it exists. But for the purposes of the rest of this course, I'm going to be focusing mostly on for each loops, as I have already up to this point, because for each loops really are the way that SideEffect is expecting us to use this type of functionality moving forward. So with that, I will catch you in the next lesson.